Okay, we're still talking about profile tolerances. Limits of application. Unless it's specified underneath the feature control frame, usually, the profile tolerance applies to the entire surface. It's an all-around profile, it's all over, or it has a defined limit. So in this, we look at a profile tolerance that is across the entire feature. Okay, so in which case here we have datum A, which is a feature size. We have a basic dimension here, which gets us to from datum B up to the top of this spherical radius. And then we have a profile tolerance of 3 thousandths. What does this mean? This means that this profile 3 thousandths applies over this entire surface. The entire surface is defined as the surface between these two obviously abrupt changes in direction. We got one right here, and then we got another one right here. So without any modifiers, that's how it is applied. Now in this next slide, we're going to look at another way to do this. In this case, we have 3 different profile tolerances based on the segment that we're looking at. Okay, so this feature control frame says from point A to point B, we have 20 thousandths profile tolerance. And here is what that means. 20 thousandths total wide tolerance zone. Whereas from B to C, we have a 10 thousandths tolerance zone. And then from C to D, we have a 20 thousandths tolerance zone. So these are profiles applied between noted limits. And here's how we would do an all-around profile. We would use the all-around symbol on the leader that we use to put the feature control frame out there. Now what does that mean? Okay, what does that mean is we have this profile defined, and then we have a 20 thousandths wide boundary all around that theoretical profile within which the boundary of the profile shall fit. Again, what's missing from this drawing is all of the basic dimensions that define what the locations are and what all of these dimensions are. Those have to all be basic dimensions for this profile to work properly. So let's compare the all-around profile application to an all-over application. In this case, we have 2 circles on the leader line. And what that says, it applies to all features on the part, and it may apply additional tolerances. Okay, so what I'm talking about here, it's applicable to this line here, it's applicable to this surface here, it's applicable to this surface here, and it's applicable to this surface here. Note that all of these dimensions are sized with basic dimensions. That is an all-over application. Okay, so now let's talk about how to apply a profile tolerance. When we did this one right here, okay, we have our theoretically perfect profile of 1 slot, and then we have an equal bilateral 20 thousandths tolerance zone around there. So what happens is when I say equal bilateral, the tolerance zone extends inward from the profile and outward as well. That is an equal bilateral profile tolerance. Again, this is shown here in this slide here. It's an equal bilateral tolerance zone. It's centered on the true profile, and it's assumed unless otherwise specified. Okay, so equal bilateral. When you put that tolerance out there, equal bilateral. Now, if it's unequally distributed profile tolerance, you need to specify that in the feature control frame. It may be applied to more material. Unidirectional tolerance may be applied to less material. Unequal disposed tolerance may be allowed one side more than the other. Okay, so let's take a look at this. We have 2 practices here for this slot. Okay, so we have 2. This is 022 is the tolerance zone, and it's under by 0.22. Okay, so what that means is these dimensions over here, if they were all basic, defines our theoretical profile, and the tolerance is 22 thousandths on the inside of that boundary. So that's how this U is applied. Okay, a unilateral tolerance to the outside of the material adds material may be indicated by placing the unequally disposed tolerance symbol inside the feature control frame and repeating the tolerance value. Okay, so that's how we do a unidirectional. Here's another unidirectional here too. Okay, so in this case our tolerance is 15, and then it's a unilateral tolerance, and it's 0 is the second number here. Now what that means is that if we have our boundary defined by the basic dimensions, our theoretical profile of the slot is located on the outside of that. Okay, so it's unilateral. Okay, profile tolerances may be used to control form only with no datum features references, form and orientation. Data features are going to be referenced, and then form, orientation, and location. Data features referenced and basic dimensions to locate the feature. Okay, so form only, no datums. Form and orientation, you're going to have datums. Now form, orientation, and location, you're going to have datum features and basic dimensions to locate the features. Let's talk about some examples of this. Okay, so here we have a profile tolerance, form control only, in which case we have our surface profile. We have no datums. Okay, so really what we're doing is we're taking this surface right here and we're applying a control to it. Now this one controls orientation as well. Okay, so what we have here is, hey, when you're sitting on datum A and datum B, then it defines where these surfaces are. So what we're going to do is we're going to try controlled location, the orientation and the form with this one. Okay, now what we're talking about is being able to control form, orientation, and location. The difference between this one is now we have these basic dimensions. Now this basic dimension here defines where the starting point of this profile is. Okay, and then that's how you know you got this datum B in here, and then you got this basic dimension that controls that form. Okay, so like most of our other tolerances, what we have is the 600, and that would be 611 down to 589. Okay, which is essentially the tolerance on the 600 thousandths dimension based on this tolerance here. Okay, so then that defines the profile there. One more slide I want to talk about is profile tolerance applied to a conical surface. Here is what that means. Essentially, by applying the profile tolerance this way, with your basic dimensions here, and then your basic dimensions here defining the size of this cone, we really have a tolerance that's defined by two concentric cones orientated about datum axis A. Okay, that's the end of this presentation. Thank you.